1, 2. Good afternoon, and here we go. We're going to be looking at inequalities this afternoon. And the first one is to work out the equation, the three inequalities satisfied by all the points in the unshaded region. So here you go. I'll give you 2 minutes to see if you can work those out. Okay, so here we go. We've got this line here where everywhere on the line y equals 3, all the way along that line. And we want to be above that line. So we want y to be greater than 3. Now dotted means greater than. If it was a thick line, we'd have greater than or equal to. So that's the line y is greater than 3. And the other easy one here is where x is always 1. And we want x to be this side of it, so therefore x must be greater than 1. So we've got two quite nice easy ones to do there. Then we've got this one, okay, which is a line that goes through 4 and it goes through 1, 9. So let's work out the gradient of this line. Is probably the easiest thing. So we go 1 along and it goes 3 down, 1 along, just checking accuracy. So it goes 1 along, 3 down. So the gradient is equal to -3. That line, okay, and let's pick a point it goes through. So pick the point 3, 3. So therefore, if you use the equation y minus y1 equals mx minus x1, you need to watch one of my straight line videos if you don't know that. Okay, this is a point, y1 and x1 is the point on the line, 3, 3. So you've got x1, y1 equals 3, 3. And we know m is -3, so we've got y minus 3 equals -3, a lot of 3's going on here, x minus another 3. So we know that that line is going to be y minus 3 equals -3x plus 9. And let's just make it nicer, y equals -3x plus 12. Probably could have guessed this was going to cross at 12 and done it that way. Y equals mx plus c way. If you want to do the y equals mx plus c way, once you've got the gradients -3, well, you know it's going to go 1 along, then 3 up, and we'll cross at 12 is the other way to do it. Next, we need to work out which side of this line we want to be on. We want to be on this side of the line. So put a point that's on this side of the line into the equation and see what happens. So if we put 0, 0 into it, so we've got 0 is equal to -3 times 0 plus 12, and that gives us 0 equals 12. Well, it doesn't equal 12, it's less than 12. So to make that into something that is true, we turn that into 0 less than 12. So therefore, you want this to be a less than sign. So y is less than -3x plus 9. The alternative is just a guess. You could just guess y is less than -3x plus 9. Put 0, 0 into it. Sorry, the mouse is being very sensitive. Put 0, 0 into this. So 0 is less than 0 plus 9. Yes, that is true. And you're away. Okay, let's move on to some quadratic inequalities. Now, you've got to be careful. It's not as simple as you think. I'm just going to give you 30 seconds to do this one. I've got one very similar for you to try after. So do this one and see how you get on. Right, I made a mistake. Sorry, I didn't tell you what the question was. The question is obviously to solve this inequality and then try and represent it on a number line. Now, most of you, I bet, wrote straight away that x is less than 12. Now, you've got to be careful here because if we were to draw a graph of y equals x squared, there's y equals x squared, and we make the y value equal to 144. So we look up 144 on here. Then, where is it less than 12? Where is x squared less than 144? Well, this graph, the y value, is going to be less than 144 all the way along here. That's where you're less than 144. So we've got this value where you're less than 12, but we're also going to be bigger than -12. So we need that put. So it's going to be bigger than -12. Now, a quick thing to check is if you're not sure whether it's going to be bigger than or less than, is to just put some numbers in and see what you get. So if we were to do a number line, we could put 12 there, 10, so 2 4s, that's going to be 8, 4, 0, 4, 8, 12, so it's minus 12 to 12 and 0 there. Now it's a less than, so we draw a circle, and then we want to join that up with a line. And that represents that on the number line. Okay, that's how you do that. So remember, when you've got these x squares, be careful, because if you're solving this equals to find the boundary values, you know that x can equal 12 or x can equal minus 12 to equal when x squared equals 140. So bearing that in mind, and notice there's a twist in this one, it's greater than 81. 30 seconds to have this. Right, so there we go. So you'd have started off with x is greater than 9, the squaring both sides. Now if you want to be x squared is greater than 81, think about the graph, think about 81, and where if you make y equals, got y equals x squared, and we make that equal to 81, and we want to be greater than it, you'll realise it'll be here and here. And this value here is 9, and this value is minus 9. Okay, so therefore it's going to also be less than minus 9, and we can't just write less than minus 9 because that doesn't quite make sense. Minus 9 is less than x is greater than 9. That doesn't make any sense, so we can't write it like that. What we can write is or x is less than minus 9. So to put this on our number line, and or to go minus 3, minus 6, minus 9. So 3, 6, 9, and then we want greater than, so we want a circle, a line going that way, and we want less than, we want a circle going that way. If it's an equals here, another line underneath, then you fill these circles in. So that's x squared is greater than 81. Therefore, x can be greater than 9, or x can be less than minus 9. If in doubt, put 9 and minus 9 on, put 0 in, see if it agrees, put 10 in, see if it agrees, put minus 10, see if it agrees, to get your signs the right around. There's another way of having a look at it. I'm going to step it up again. Again, another 30 seconds to do this one. Right, so first of all, hopefully you divided by 4 to get x squared is less than or equal to 1. And therefore x is going to be less than or equal to 1 as well when you square it 1. Now, again, we're going to have a boundary value of minus 1. Think about a y equals x squared graph again. And you think where it's 1. And then we can see we get 1 here. And then we can see we'll get minus 1 here. Where is it less than 1? Well, the graph is all less than 1. The y value is all less than 1 between these values. Okay. So therefore, we want one colour. So we want x to be greater than or equal to -1 and less than or equal to 1. So notice when we're between the values, you can just write it as one inequality. Whereas before, where we're outside the values, okay, we have to separate the inequalities out to 4. So drawing it on here, let's make this 0, make this 1 here, and make this 1 here. Notice I'm filling it in because we've got less than or equal to symbols. So that is our illustration on the number line. Okay, make it slightly more complicated. I'm going to go all the way through to a proper quadratic when you go solve it on its own, which is actually almost getting to level 8 standard. So this one, I think I'll give you a minute, just stepping it up a little bit. Right, so do the same process again. Let's square root both sides. So get x plus 4 is less than or equal to 10. But because we wanted squared, let's just think again about our x squared being less than or equal to 100. And we get the x value is 10 and the x value down here is -10. So it's going to be less than or equal to. So it's going to be between here. So it's going to be between -10 and 10. So we can write greater than or equal to minus over here. So let's take away 4 from both these 10s. So take away 4 from -10, we get -14. That's x. Take away 4 away from 10 and we get 6. So we can see that x is going to be between 6 and 14. And I'm just going to put a number in here and just call that 6. I'm just going to make up a number here, call it 14, and then draw them. Doesn't really matter what the scale is, just to illustrate what it would look like on our number line. So remember, do the square thing, work out your two values, and then take away 4 from that value and take away 4 from this value. So let's have a go at the next one. Do 60 seconds on that. Sorry about that, missed with the mouse click when starting the timer. I hope it was roughly about right. So do the same again. We're going to square root both sides, so we're going to get x minus 9 is less than or equal to 6. Think about what the x squared graph is. This is y equals x squared, and where it equals 36, and we got 6 here, and then we got minus 6. Those are our boundary values. And we want to be less than 36, so less than 36 is all this part of the graph. Okay, so it's between minus 6 and 6. And now we're going to add 9 to both values. So add 9 to minus 6, we get 3. Add 9 to 6, we get 15. So x between 3 and 15. So I've got a 3 here. And I've got less than or equal to, so I'm filling in the dots. I'm going to put a 15 here. And I fill in the line. Filled in dots. Okay, next one. Okay, now we've got a full quadratic, so you're going to have to factorise on this one and then think about what happens with the inequality. I'm going to give you 2 minutes to look at this one so as you can play around with it and see if you can get it out, because the factorise shouldn't take very long. Play around with it, see if you can get the inequality out correctly. Do a bit of testing with the numbers afterwards, put them back into the original equation to see if they work. Here we go. So we're only going to have time for one more of these practices. If you don't think it's enough practice for today, actually the level 8 lesson starts from here. So there'll be some more practice on that if you hang around for the level 8 lesson. So we've got to factorise this. So let's think about it. What times together give me 14 and can be combined to give me 3? There's minus 14, which makes life a bit easier. So that gives us minus 5 and 8. Hopefully your factorising is getting to the stage where you just see these. If you don't, find an online thing to practice your factorising and make sure you can get it, so you can just do it by looking at it. You should be able to do one like that by looking at it by now. If you can't, go away and do some practice and you will be able to do it. So we've got x plus 8, x minus 5 is greater than or equal to 0. Well, how do we work out where our region is going to be? Well, what I do, I think is the best way to do this, is imagine if it was equal to 0. Let's work out what does that mean. If we were to draw the graph y equals this, then if y equals this, then we realise the 0 is equal to our y value. So if we were to draw y equals this tells us it crosses at minus 8. This tells us it crosses at 5. If we were to draw a graph of y equals all of this squared plus 3x minus 40. Minus 40. I've just gone off the screen a little bit there. If we were to draw that graph, that's what it would look like. It would cross at minus 8 and cross at 5 because the y value here is 0 and the y value is 0 all the way along the x-axis. This actually tells us when you solve this equation equal 0, it tells you where it crosses the x-axis. So we know that it's crossing at minus 5 and 8, so 5 and minus 8 is our boundary values. They're our boundary values to this equation. And we want to know where it's greater than 0. Well, if this is our y value, then the y value is greater than 0 here and here. The y value is going to be greater than 0 that way and greater than 0 that way because the y value is all up here. And down here, the y value is less than 0. So what our solution to our equation is, x is going to be less, it's got a less than or equal to minus 8, or x is going to be greater or equal to 5. Okay, and actually what I've done there is almost illustrated what we're going to put on the number line. So I'm going to put 5 there, draw a line, arrow, minus 8, not very neat, draw a line that way, that illustrates our inequality. So remember, try and factorise. If you can't factorise, just get out the boundary values, draw where they are on the line. If it's a positive x squared, draw a U-shaped graph. If x squared is negative, remember, that gives you an N-shaped graph. Easy way to remember them: positive, happy face; negative, unhappy face. Okay, so have a go at the next one. Okay, so I hope you remembered to make it equal to 0 on this side by taking it all side. So remember, quadratics, you always like to, if you want to solve them and find out whether they're equal to 0, you need to make it equal. Because we basically find the boundary value by thinking, where is this equal to 0? So if we look at where x squared plus 50x minus 1, 3, 0, does that one factorise? I'm just trying to think. I've got 11, 11 doesn't seem to be, it's not 11, 11. Can't see straight off my head how that factorises. So when you can't do that, then you can complete the square. So I'm going to get minus 50 and get minus 1. equals 0. Sorry, not 50, it's minus 25 squared. Sorry. Times by 2 squared. Minus the 25 squared. So I'm going to x plus 24 squared plus 625. They're lovely numbers, aren't they? 625, 725 on the other side, plus another 31 gives me 6. I don't know if that by roots. So just I've got a calculator on. Look. No, it doesn't square root. So we get x plus 25 equals plus or minus the square root of 756. And therefore x is equal to minus 25 plus or minus the square root of 756. Now you probably can simplify that down. I'm not too interested in that right now. But what I am interested in is we've got an x squared graph that's going to cross at minus 25 minus that. And it's also going to cross at minus 25 plus that. And we know this is going to be positive because that's bigger than 625. So therefore it's going to be bigger than this value. So now we know we want less than 0. So it's going to be between these two values because it's less than 0 down here. So therefore it's between the two values. Okay, roughly, it doesn't really matter. Okay, so we know it's between those two values. So our solution is going to be minus 25 minus root 756. Not 56. Oh, sorry, well spotted somebody. No wonder it was so hard. Doing a stupid problem. I was doing it as if, well, I'm going to carry on doing it as if it's 50x. It would be a good lesson for you. I misread the question. Sorry about that. Anyway, we'd have that, and we'd have that, and then we'd have that. What I will do is I will go back and now do the question you all thought you did. So I wasn't expecting the question to get easier after doing that one. Okay, because this was in the order on the my maths lessons. I wasn't expecting the question to get easier. If you're doing it, so I should have got x squared is less than, take 50 away from that, I get 81, which is x is less than 9 and x is bigger than minus 9. That would have been nice, wouldn't it? I saw someone in chat helping me out. We don't fill in the circles and we get minus 9 and 9. Thanks, Beast FC, whoever that is. Sorry about that. But now you see how to go about doing one that's a lot more difficult than that. Now that's about half an hour's up, easily. So these questions that I had planned for later are all just the same sorts of questions, the same techniques, and there's a few more to practice. What I suggest you do is you go on to My Maths and practice some more. So I put a My Maths link on there. If you go onto the OneNote, you'll see there's a My Maths link to these questions on OneNote. Now I'm just going to take a quick break and set up the level 8. There'll be some more of these to do and some trickier stuff as well. Right, welcome to the level 8 section. So you can see we're just starting off where we left off with level 6 and 7. We have a quadratic inequality for you to have a go and solve. So 2 minutes, let's see how you do. Right, if you're getting the hang of these, you should be able to knock these off in about 60 seconds. Let's see if it can be done. So if we're factorising this, we want to get x. We've got 14 and we want to get 9. So 7 and 2, x plus 7, x plus 2. And remember, we're going to look at what that looks like when it's equal to 0. So it's going to cross at minus 7 and it's going to cross at minus 2. So the y-axis will be over there somewhere. We want to know when it's equal less than 0. So it's between here and here that's going to be less than 0. So therefore x will be greater than or equal to minus 7 and less than or equal to minus 2. So put minus 7 on a number line, fill the dot in. So 5, 4, 3, 2, we can put that on there, 2, minus 2, and then we fill in the between them. Even with explanation, you could do that in 60 seconds if your factorisation. Good enough. So just recap on the skills on that one again. Remember, we look for where the boundaries are when we have y equals to this. There's a graph, y equals to that, and it crosses at minus 7, minus 2, and I know it's a U-shaped graph because of positive x squared. Let's have a go at another one. Let's see if you can knock this off in. Okay, did you manage to knock this off in 60 seconds? Well, here's what we do. We make it naught over here, so x squared minus 3x minus 4 is greater than or equal to naught. And we look at that is going to be equals to naught, our boundary values. Right, last time I was a bit lazy and just did that straight off. Because these are boundary values, it's not really the same problem. So we're looking for boundary values. We factorise, we get minus 4, and we get x plus 1. So if we draw a sketch of that graph, it's going to cross at 4 and minus 1. Minus 1, so we put the minus 1 there, and we put the 4 there. And we want greater than or equal to 0. So this curve, y equals all of that. Okay, the y value wants to be greater than 0. So where does that happen? Here. So we're going to be looking at x is going to be less than or equal to 1, or, okay, because it's split, x is going to be greater than or equal to 4. Draw is on our number line, so there's minus 1. Fill it in because it's less than or equal to 0, 2, 1, 2, 3, 4. And draw that. And we get visual representation on the number line for question. Let me just quickly remind myself of what it was going to do, that and that. So actually, I think we're going to leave enough of these because all that happens is the factorization just gets a bit harder. Actually, in this one, you could divide throughout by 3. This one could probably divide by can't divide by 3, but it's a trickier factorization. All they are is harder factorizations. Same method, harder factorizations. See if you can do them. And always click on the My Maths link to go and practice and get them checked. Okay, if you didn't get them first off, practice again after the end of the video with a video to help you, and then practice again in a week's time to make sure you can still do them. Right, trickier problem. Bit of sets included in the inequalities. A really good thinking question. So let's give you 3 minutes to see if you can get this. Okay, there's lots of ways to do this. You don't actually really need to do any algebra on this if you don't want to. Let's just have a look at it with the algebra. Because what you could, because you know you've only got from -8 to 4, you could just put them all in and see which ones agree and which ones don't. It's not going to take very long with just 12 numbers, well 13 numbers. Okay, because you know they're integers, put them in and you can work them out. But anyway, let's just do the algebra anyway for the practice. So x squared is less than -6x plus 7. So take it all to the same side, x squared plus 6x minus 7 is less than 0. So x plus 7, x minus 1 is less than 0. If you think of that as an inequality, we got -7 and 1, where it equals to 0. We want it less than 0, so it's going to be between 7 and -1. Now it's less than, so we can't include 7 and we can't include 1. So we start off with 6, 5, 4, 3, no, wrong, sorry, -6, -5, -3, -2, -1, 0, and 1. It just, no, not 1, doesn't include that because it's strictly less than. So it's only those numbers. It's a bit disconcerting because these are the blanks left by my maths, but we don't fill them up. Maybe that would give the game away a bit too much. Anyway, doing x squared and doing the next one, x plus 1, x minus 3, is going to be a bit easier. And actually, it's a bit quicker doing the algebra than testing all the numbers. So we know that we're going to cross at -1 and we're going to cross at 4. No, not 4, 3 even. So we're going to cross there, and we want that to be less than 0. So between those two values there, okay. So we want it to be between -1 and 3, again strictly less than. So we don't include -1, so the first one in B is 0, and then we're going to go 1 and 2, and we can't include 3 because it's strictly less than 0. These are the boundary values, so therefore they can't go in because there's no equals to. Now we want not A. What's not in A from the universal set, so that's going to be -8, -7. And then we've got all the numbers 1, 2, 3, and 4. Not A intersect B. So how many of these are in B? It's just 1 and 2. Okay, is how you do that one. So you write down, the easy way to do this is write down what's not in A, and then we've got the list of numbers, and then see which of those are in B, and it's just 1 and 2 is our answer. Okay, so they've really gone to town on this one. A intersect B, so let's work out A intersect B first. A intersect B is where they overlap. Well, they overlap at 0. Okay, A intersect B is equal to 0. It's only one value. It's not an empty set. It's a value of 0 that's in both sets. Now we want A union B not. Not very helpful. So A union B not. So first of all, think of A union B. So it's all of these and all of these. So it's all the numbers from -6 to 2. So therefore, it's going to have A union B. So not those. So we're going to have -8, -7. And then what else are we going to have? We're going all the way up to 2 and it goes to 4. So we go to 3 and then we go to 4. Because the B went up to 2 and overlapped with the A, it's just the 3 and 4 that's going to be in this set. I'm going to use a rubber just to neater so you can see that that's an equal sign. So that is those two sets, and we want to union these sets. So it's those 4 numbers and the 0. So if we start at the lowest number, -8, -7, bring in the 0 because it's a union, that, and then bring in 3, and then we bring in 4. So that is how you go about doing those. So it helps to know your symbols. The little dash means not, that means intersect, which is the overlap. The union means or, effectively. It could be one or the other. Okay, our last question here is to do backward graphs of inequalities and then to try and solve a real world problem with them. I'll give you 3 minutes to have a go at that. Finish off with going through that question. Right, that was probably quite a big ask to do that in 3 minutes. So anyway, we'll go through it so you know how to go about doing it. So the first thing is to find the inequalities, and you've got given this information in the question. He sells paperbacks for £5 and hardbacks for £6, but he has £71 to spend. The amount he spends could be less than 71, less than or equal to 71. So P, 5p plus 6h must be less than or equal to 71, and that's this line here. So this line here is 5p plus 6h equals 71. And this line is going to cross the p-axis when h is 0. So therefore, if h is 0, 6h is 0. So therefore, 5p equals 71. So this will equal 71 over 5. If we're on the hardbacks here, we will find this crosses here where p is 0. So therefore, if p is 0, we've got 6h equals 71. So this is 71 over 6. He wants to buy more than 4 books. So this means that p plus h must be greater than 4. And that's this inequality here. And this is going to be therefore p plus h equals 4, this line, the boundary value. And it's going to, when h is 0, p will equal 4. And when p is equal, h will equal 4 to get those values. So that's how you can do that. Now we need to show the unwanted regions. Well, we want to be less than this. Easy. We want to be greater than this. Easy. Now it wants to buy at least twice as many hardbacks as paperbacks. So the number of hardbacks has got to be greater than or equal to 2 times the number of paperbacks. That's h equals 2p. Now we want to think of a number. Which side of this line are we going to shade to get h is greater than or equal to 2p? Pick a number in here. So 5 will be a good number, just around about there somewhere. 5 on the h column, and p is 0. 5 is greater than or equal to 2 times 0? Yes, it is. So we want this. So this is our region of all the things, all the numbers which are okay. So show the unwanted regions. It says by clicking on them because I nicked this off My Maths. Okay, you can go on My Maths and practice this. Now, what is the greatest number of paperbacks a customer can buy? The greatest number of paperbacks a customer can buy is where these two lines cross. And what is the smallest number of hardbacks you can buy? Where these two lines cross, or as close to that as possible. So let's scroll down and solve those two equations to work it out. So we've got 5p plus 6h equals 71, and that's going to be combined with h equals 2p. Well, as h equals 2p, we can replace h with 2p equation. So you get 5p plus 6 times 2p equals 71, and then you're going to get 17p equals 71, and therefore p equals 70. P equals 17, which is about 4.17. So therefore, the greatest number of paperbacks is going to be 4. It's not going to be able to, can't buy 4.17. The greatest number of paperbacks you can buy is 4. What's the smallest number of hardbacks you can buy? So therefore, you can do p plus h equals 4 combined with h equals 2p. So therefore, replace h with 2p. So we're going to get 3p equals 4. So p equals 4 over 3. So the least number of paperbacks you can buy, you can't buy 1 1/3 paperbacks. So therefore, he's going to have to buy at least 2. It's going to be this side of that line. So the least number of paperbacks you can buy will be equal to 2. Okay, that finishes off that question. It was quite a tricky one to do in 3 minutes with 2 simultaneous equations to solve, as well as working out all the graphs and stuff. Remember, you can go to My Maths. I've put the links on some of the pages. There we go. There's a link on that page. Or you can just go to My Maths and find them. It's called, just go to the booster section Okay, go to the booster sections and look for the booster 8 to 9 on inequalities, and you can practice the questions that way. We'll see you tomorrow, and tomorrow's topics are going to be sequences. Okay, recognizing sequences. And maybe finish, I know there's some level 8 algebra we didn't finish off as well from a previous lesson we'll do. Okay, thank you. See you tomorrow.